So it will not be as neat looking. I apologize. Can we get those stools? Anybody with stools next to them, could they put them on the ground, please? Appreciate you. So let's go ahead and review some of the stuff that we should all know. Everybody should be writing this in their notebooks. I will be expecting all these early days notes in your notebook. Somebody forgot their notes. Several people forgot their notes. I was able to deliver most of them. I do have one other person here, Deshana R. If anybody knows who she is, if you see her or have lunch with her, just let her know that I have her papers. Remember, I'd like to see binders. I'm looking around the room. I still see spiral notebooks. That concerns me because there will be a grading period and you will lose points for not having notes in a binder. Bless you. I will not be looking through a stack of papers trying to figure out where everything is. You will get a 0. So you need a 3-ring binder. It's the only school supply you need for this class besides pencil and paper. You're talking, but you're not listening to me. You need a 3-ring binder. In fact, it's interesting, the 2 people that were talking are 2 people who don't have a binder. So it's interesting. Yeah. The date is wrong on the board. August 14th? Oh, you mean August 9th. Yeah. Yeah, so you can change that. That was notes that was left over from August 9th. You can get up and erase it if you like. So what we're going to do is we're going to go over, let's go ahead and start by reviewing some of the things that we know, some of the things that everyone in the room should know at this point. And it is August 14th. So the first thing to consider is your computers. When are they starting? When are you getting them? Does anybody know? Today. Interesting. Where did you think? Why do you think today? Who told you today? No, or this week. Okay. Yeah. So if you open up your weekly bulletin, which I understand you don't have your computers, but you do have your cell phones, and your bulletin is sent to you through Jupiter, correct? Mm-hmm. Then everyone should know when you're getting to your computers, which is this week. When this week, we don't know because they're still trying to make sure that everyone has a login. They don't want to give everyone a computer and then have some people without logins. They don't want us using Schoology really until we have logins for everyone and everyone has a computer. And it's going to minimize their logistical needs. So, and puts us behind a little bit, but we have a lot to do that we can do without a computer. So we'll just have to adjust. So that's this week. You will be getting your computers theoretically, hopefully. Wish upon a star. We're going to get those computers this week. Where are you going to find your lessons? This recording I'm making now and all the other recordings. In Jupiter. Yeah, for now, you'll be finding them in Jupiter. If I were you, instead of waiting for me to post them and send them to me, or post them in Schoology once we're all in Schoology, I would subscribe to the YouTube channel. Then you'll get a notice every time the new one's posted. You don't have to wait. You don't have to ask. You don't have to chase. Or you can do like so many kids do and just chase after it. I don't care what you do. But that's the easiest way to do it, is to subscribe to the channel. Some of your parents have already subscribed to the channel. So it's just real easy. But it's up to you. That's how you'll get your You obviously don't have to watch the videos if you captured all that you need from class. All right? All right, so we're all good with that? You have bins here. Your bin is the first period, so it's the very first bin. Do you see them labeled? Yours says first period. Could you close the door on your way in? Thank you. Yours says first period. Don't put your stuff in someone else's period. Make sure that you have your name, the period, and the date on your paper, and the title. What is it that you're turning in? I had someone turn in English work to me as I was grading over the weekend. I don't need your English work. This is why I want you to have nothing but biology in your binder. Is that clear? Yes? Because some of you are going to keep making that mistake because you're not listening. You're going to do what you want to do. Do you have a pass, a tardy pass? You have to go to the office and sign in tardy. So make sure, at the very least, you're putting things where they belong. If you don't put them where they belong, you're going to run into issues. Okay. Your work you've done so far. You have your quiz, right? That you completed on last Thursday. You have your syllabus that you were signing page. Some of you turned in the whole syllabus. What do you think? Why do you think someone who would think in this class, after all we've discussed, someone would still think that if something's one day late, they would have 45% off? They didn't read the syllabus. They didn't understand it. They didn't ask questions. They didn't reflect. They didn't reduce it. They didn't recite it. And how stressed out is that person going to be when they're a day late with their work and they're thinking they're going to lose 45%? How stressed out are they going to be compared to you that you know you're only going to lose 10? They're going to be much more stressed out. So you see, the people that don't pay attention, they're usually the people that are mostly stressed out. They don't record, they don't reflect, they don't reduce, they don't recite, they don't revise. They stress themselves out more. That stress makes them do less of that, which stresses it out more. It's called the positive feedback. You might as well go ahead, and that is something in biology that we're going to see over and over again. It's called positive, and hopefully the pencil's working now. Let me see. Yeah. It's called positive feedback. Write it down. Too many people think positive feedback means a good thing. It does not. It's the worst thing that can happen is positive feedback. I'm not talking about telling you did a good job, right? That's different. We're talking about a loop. And let's look at the loop. You're stressed. Which makes you do what? Makes you do less. All right, did you sign in tardy and get a tardy pass at the office? Thank you. Which makes you do less of the 6 R's that we've discussed, which what ends up with you not doing well for whatever, however that looks. You not doing well leads you to what? Right, it could be failure, it could be a D, it could just not be, it could be get yelled at from mom for not getting 100% of your homework, not doing extra credit, it could be not getting to go to Cedar Point, it could be not wanting to disappoint your parents, not wanting to be embarrassed to your friends, whatever that means to you, right? You get not doing well, which leads to more stress, which leads to you do what? Less of the 6 R's. You're not recording. Why aren't you recording? Because you're stressed out. Why are you stressed out? Hopefully not anything in this classroom, but it could be from home, or it could be your girlfriend or your boyfriend, or you spent too much time playing video games. Whatever the life choices are, your body, your mind is stressed out. You're not focused. If you're not focused, it's going to lead to less of the actual learning, which is these 6 R's, which means you're going to not do well, which is going to stress you out more. What are you going to do when you're not doing well? You're going to do less. Some people might say giving up. I would say it's more like avoiding. It's a strategy we humans use. Humans avoid, right? If you can avoid the problem, then it's not anything you need to deal with right now. And so it is a positive feedback loop that ends up really hurting you. Just to give you another sense of how positive feedback loops can hurt, we can go globally and look at carbon dioxide, CO2, producing CO2 from fossil fuels. Burning fossil fuels. That increases CO2. Everybody, CO2 is carbon dioxide. Does anybody know what that does when it's put into the air? There should be a lot of people who know what it is, but let's go ahead and ask, see if anybody knows. What happens when carbon dioxide is released in the air? Anybody? No one's heard of this? I'm sure you have. I'm sure you're just not thinking about it this morning. Increased carbon dioxide, burning fossil fuels. What is it? What happens? Say what? That's right. You got it. It traps heat in the atmosphere. CO2 is one of those global climate change gases. You're going to see CO2 a lot. You're going to see CO2 a lot in this class in a lot of different ways. So you might as well you produce CO2. Every time you breathe out, you're making CO2. That carbon, no, dear, sit on the other side of the table. On that side. Oh, do you need to sit in front? Do you want to sit in front because you can't see the board? Is that what you're doing? You can sit here. That way you can face the board. Traps the heat. That trapped heat in the atmosphere, what it does is increases melting of the ice. It also leads to increased fires. Anybody smell the air over the last month? All the smoke that was coming. Where'd that smoke come from? Canada. The fires in Canada. Ocean, yeah, this is ocean. Increases fire risk. When that ice melts, what does ice do? What color is ice? White, right. Snow and ice is white, right? Mm-hmm. What happens when the sun's light hits white? Huh? In a prism, it would split in a color. You're right. But what is white? When any light hits white, what does it do? It reflects. And now all that sunlight, heat, energy, and stuff reflects right back into space. So what do you think is going to happen when the ice melts? More heat in the atmosphere. So let me go ahead and do that. So it increases. So this increases the melting. The increased melting increases the temperature. The more fire also increases temperature, but also does what? Increases CO2. So you see all this positive feedback? Everything's about increasing. It's going to run away from us, right? Like a snowball rolling downhill. That's a bad thing. So it's just this is what we call a positive feedback loop. This is what nature does not want. Nature doesn't do this. Nature has a lot of negative feedback loops to keep everything stable. But in a positive feedback loop, things get out of hand. Positive feedback loops, what they do is they destroy equilibrium. It's a fancy word for keeping everything the same. So this is why your behavior this is how your behavior can cause you to get in one of these positive feedback loops and end up putting you in a real bad spot, including depression, alcohol abuse, drug usage, all that stress, all that can come from this positive, just continuously doing the thing that stresses you out, which leads to outcomes that stress you out, that makes you do more of those negative things that increase the negative outcomes that stress you out, and over again in positive feedback. This is nature. This has nothing to do with your teacher trying to tell you or control you. This is the world that you live in. I quickly talk about a negative feedback loop, a simple one, and then I'll use one that we'll refer to later again when we look at glucose regulation in your blood. Do you know what glucose is? Sugar. That's right. It's a simple form. This is one of the main sugars that we'll be dealing with in this class. So let's take a look at your house. You have a thermostat in your house. It has two needles. One is a thermometer. The other one's a set point. Okay, it's a thermometer. Everybody know you have a thermometer? There's one here. This one's simple. It's a red, or it goes to red and blue. Blue for cold, red for hot. Huh? I would. This is going to be a negative feedback. Yeah, those were positive feedback. Yeah, you're right. I shouldn't have it listed like this. I wanted to compare it diagonally, but let's go ahead and divide it vertically instead. That way we can put negative feedback. Let's take a look at a negative feedback loop. Again, we have a thermometer in your house. Does everybody here have air conditioning? Can we go in the winter and do heating? Because everybody has heating. Is that fair? All right. So you set your thermometer. Your mom sets it to 70 degrees Fahrenheit. Now, it gets cold. Cold air, it gets cold outside. What happens? What does the thermometer do? What does the thermometer do to if it gets cold? It turns on the heater, right? It turns on the furnace. Furnace turns on. Which produces heat. Do you see how that's negative? Does everybody see how that's a negative?
That's a N-A-C-E.
Furnace. Yeah, that's an N. Yeah. So the cold air signals to the thermometer, turn the furnace on. That makes it hotter. Correct? So that's a negative. So there's your negative feedback. It's going to do the opposite. So negative feedback means it does the opposite of the stimulus. The stimulus here is cold. The opposite of cold is turning on the furnace. It gets heat, it gets hot. Now what happens if it gets too hot? I can turn on the air conditioner or could just turn it off. So if it gets too hot, then it turns the furnace off. Which then makes it cold. If it gets too cold, then it turns the furnace on again. If it gets too hot, it turns it off, on, off, all day long. So what happens is that you keep the temperature at around 70 degrees Fahrenheit. So your thermostat and your furnace system keeps the temperature around. If it gets too cold, it's going to heat it up. If it gets too hot, it's going to turn off. Hot, cold, hot, cold. It keeps the temperature around 70 degrees. It keeps the temperature somewhere around here. Doesn't let it get too hot, doesn't let it get too cold. If it's working right. Do you agree? That is equilibrium. Does that equilibrium mean it stays still? No, it doesn't. It just means that in fact, it's changing. We call it dynamic. Dynamic because it moves, equilibrium. It allows us to keep homeostasis. The root word here is homeo or homo, which means the same. It means the same. And the stasis means still. So it keeps sameness. It keeps sameness. How is it that what is your temperature? What is your homeostatic point? What's your homeostasis for temperature? At what temperature do you stay at? You should know. Everybody knows. You watch enough Grey's Anatomy. Yeah, your body. You all watch Grey's Anatomy, or most of you do. You watch some show. You've had a thermometer stuck up your butt or in your mouth. When you were a baby, they put one up your butt. They have thermometers. Yes. They get more accurate temperature. My God, how old are you? They have thermometers that test your forehead. That's right. Your homeostatic point, and everyone's a little different, but about 98.5 degrees Fahrenheit or 100 degrees Fahrenheit. How do you know that's your homeostatic point? Instead of saying, I don't know, how could you have guessed? Yeah. That's right. Excellent thinking. Over 100 is a fever. So I know it's probably not too much over 100. And what happens when you get too cold? You freeze to death, but we call it, hypothermia. So we know we can't be too cold. We know it can't be too hot. We know we have to have a range. We have to have this range of homeostatic range as well. In fact, that's what doctors measure. When you go to a hospital, 90% of the things of those machines are measuring their temperature, which it better be somewhere in between these, your blood pressure, your glucose concentration in your blood, all these different measurements, the pH of your blood, all has to be within a normal, what they call normal. They call the homeostatic point normal. When they say normal, they mean average. It's within a range. Everybody okay with that? Somebody's not okay with it. It's the same person that's still having that positive feedback loop that we started the day out with. The same group of kids that keep feeding into the same behavior. They just can't focus. So, dynamic equilibrium, homeostasis. You do it with blood glucose. Who's heard of diabetes? All right, you three need to split up. You came in. Why don't you get up and sit up here? Let's start with that. That way I don't have to look at the eyes, especially the kids that come in late and they're talking. All right. Let's quickly look at diabetes. We're going to get back to all this homeostasis. You don't have to learn it all right now, but you should have some idea what we're talking about. So you have blood sugar. Anybody know what normal blood sugar should be? Anybody have? Oh my Lord. There's a towel right over there. Go get it and clean it up. It doesn't matter. Say what? 85 is within the normal range. Yes, it's on the lower end of normal. Yes, 70, 60, 85, 100, anywhere between 100 and 70. If you have anybody who's 70 is probably on the lower end, but what you would expect to see is someone's blood glucose going up and down within this range. After you eat a candy bar, you'll be up here. After a good night's sleep, you'll be down here. That's why we call it breakfast. Break fast. What is fast? When you're fasting, when you're not eating and drinking. When you wake up and you have your first meal, have you been eating in the middle of the night? Well, hopefully not, but some people eat while they're asleep, I guess, but it does happen. But most of us don't. So you've been fasting, correct? And so when you eat your first meal of the day, you've broken your fast. You have had your breakfast. That's what breakfast means. All right? So you're at the lower end down here when you've been fasting. You're at the upper end after you've eaten, and you just go up and down all day. And the units are not that important right now. They're a unit of concentration. So it's how much sugar you have in a certain volume of blood is how they measure it. Which means they have to take blood samples. Anybody here know anybody with diabetes? You see them prick themselves occasionally, or they have a machine that's stuck in their arm. They have to measure blood. I'm diabetic myself. I'm a type 2 diabetic, so I have to prick my blood, take my blood and sample my blood to see what my sugar level is. If my blood glucose is low, what do I have to do? Eat sugar. Isn't that the opposite? That's negative feedback. I have to do the opposite of what's going on so that I don't keep going down. Because if my blood glucose keeps going down, I will pass out and go into a coma and die. That's not good. So if my blood glucose is too low, I do the opposite, which is eat sugar. If my blood glucose is too high, if I'm on the other end, then what do? I gotta get the blood out of my sugar. I use this thing that some of you have heard of, that we used to actually first isolate it from pigs, but we use this thing called insulin. And some people have even insulin pumps that are connected. They're embedded in their blood as well, into their veins. And the machine that's on their arm tells that pump, hey, the blood glucose is too high, put in insulin. Insulin is a molecule, it's a protein that opens the doors in our tissues, in our cells, to allow sugar in and out of the blood. It's how we get sugar out of the blood. So if our blood glucose gets too high, you do this too. You just do it with you do it naturally. What diabetics have to do with machines and with needles, non-diabetics do naturally. You have a pancreas that measures, like your thermostat on your wall. It measures your blood glucose. It says it's too high. It tells the pancreas release insulin that gets the blood glucose out. If you go too low, it sends out another molecule called glucagon, telling your body put sugar into the blood. So you put sugar into the blood or take it out, depending on when you need it, all to do what? To keep everything what? Normal, average. Normal means average, that's right. To keep it around an average, somewhere between 70 and 100. You can go lower, you can go higher, it's okay. But when you get to 600, your blood is turning into syrup. Because syrup is a high percentage sugar, right? How hard do you think it is for your heart to pump syrup through your arteries and veins? Very hard as compared to blood. So if your blood glucose gets too high, your blood pressure goes up. So you have high blood pressure. It starts to stick to everything because sugary syrup is sticky. And sticking to everything causes all kinds of things, including heart attacks, including damage to your nerves. That nerve damage can be permanent. You can have blockages to your pinky toes and your feet, and they'll have to cut you ever see someone have to get their arms and legs cut off, toes cut off? They have to lose them because they lost function because the blood sugar was way too high. If it gets way too low, you're passing out. You're going into a coma. You're dying. Those are the steps. Well, I don't know why it's funny about any of that. But if you're down to 10s and 20s, you're in trouble. If you go to the hospital, they'll pump your blood full of sugar. They'll give you an IV that has sugar in it. They'll do all the things they can do to get you out of it. Yes. But also remember that could cause damage to your bodies, to your brain. Does that make sense? So even though they can get you out of the coma, that's a good thing. You don't want it to go on too long because it can give you permanent brain damage as well. So it's very important to keep homeostasis. Do you agree? Let's identify let's summarize. Let's summarize all this discussion we've just had. Let's go ahead and write a summary. So some examples of homeostasis that are important are temperature, blood glucose, and blood pressure. Homeostasis means keep the same. Homeostasis means keep the same. Let me rewrite that. We keep homeostasis with negative feedback. Positive feedback destroys homeostasis. The negative feedback creates dynamic equilibrium. All right? Now, this is an example where what I drew and what I wrote, the summary is actually longer in words than what was written on the board for the notes, correct? But if you included all the things I said, the summary is still shorter. It's still reducing. Because I'm not just writing on the board, I'm talking to you. And we're conversing with ideas and visualizations. And so if you don't draw the graphic, if you're not focused, your mind isn't focused, you're going to miss some key points. The summary, as long as it is much shorter than the 38 minutes we've been talking, isn't it? Yes, question. Yes, of course. Is that good? So even though that's a lot of words written, it's a lot less than 38 minutes of words. Gave a lot of examples. We went back and forth. You answered questions. All that was summarized here in these sentences. Are we good? Did you get it all written down? Oh, you're still writing? Yes, ma'am. Oh, I got a problem. I don't have another sign-out sheet for the pass. I was hoping to be able to print them. Can you just sign it out on the back, and I'll fill it out. I have 4 people that were absent or tardy today. 1, 2, 3, 4, 5 people. 5 people that were tardy today. Once I'm going to stop recording, I'm going to have a conversation with you up here. Am I ready? And I'm going to give you another assignment that you're going to do for the last 10 minutes while I take attendance. Is that reasonable?
Mm-hmm.
Are we good? Is everybody ready? No one needs more time to write anything down. No questions about any of this. All right. Well, let's go ahead and write the assignment down. Find examples of positive. Oh no, let's just stick to negative. We'll get to positive feedback again later. Negative feedback that keep equilibrium. You may use your you may use your phone. Two, you may work in teams. Three, it goes in your notes. Four, you will present. So I would pick someone to work with that's actually going to be here on time tomorrow. That would be my suggestion. So that's the task. You have about 10 minutes left in class today. You can work on it tonight if you like. It should be it should be pretty easy to find examples of negative feedback to help regulate. It could be anything, not just your body. It could be nature. It could be anything. It's negative. It could be a machine. It doesn't matter. Negative feedback that helps keep equilibrium.